So sometimes when you're trying to find probability, it can be easier to find how many ways something cannot happen rather than looking at the number of ways that it can happen. Okay, this is called a complement. Okay, the notation for it. So remember how we said P of A would stand for the probability of event A happening? Well, when you add that little bar on the top, now we're looking at the probability of A not happening. Okay. And sometimes it's just easier to figure out how likely something is not to happen than to figure out how likely it is to happen. And you'll see why in just a second. Okay. So when you think about what's in terms of our probability, right? We know that the sum of all the probabilities in a sample space has to add up to 1 or 100%, right? So if you look at the probability of something happening and the probability of something not happening, that covers your entire sample space, right? That's all the possible outcomes. Either the thing happens or it doesn't. There's no other possible thing. Okay. So the sum of a probability happening and not happening, AKA its complement, that has to add up to 1 or 100%. Okay. So rewritten a little bit, what this basically says is that if you take 1 or 100% and you subtract the likelihood of something not happening, that leaves you with the likelihood of that happening. Okay, so let's take a look at an example where we'd want to do this. Okay, so this problem right here, flipping a coin 400 times and getting tails at least once. Okay, so think about how we would have to look at this problem. Okay, remember when we did at least problems when we were doing combinations and permutations and how annoying they were because you had to break it into cases? So for this particular problem, the cases we'd have to break it into is we'd have to look at, well, how many ways can you get tails exactly once? How many ways can you get tails exactly twice? Exactly 3 times? Exactly 4 times? All the way up to 400 times. Like we would literally have to have 400 cases that we would have to calculate, which would be a complete pain in the butt. Okay? But what we could do instead is if the getting tails 1 or more times is what we're looking for, the only other alternative is not getting tails at all. So the complement of getting tails 1 or more times is getting tails never. Okay, and calculating the number of ways to not get tails is so much easier than calculating all of these different cases. Okay, so our sample space, these are the only 2 possible outcomes. So what I can do is if I know these guys add up to 100, I can take the complement and subtract that from 100, and that will leave me the likelihood of this happening. Okay, so what would be the complement of this situation? The complement would be not getting tails. So I kind of already did this example out for you, although it does look like the word complement got cut off a little bit. Okay, so that's the idea of what a complement is. Okay, and it can really just save you a lot of time, especially in ones where you have at least or at most kind of cases. Okay, so let's take a look at this guy. So we're rolling 2 die. What's the probability that the numbers are different? Okay, and to give you just a heads up, right, we should remember this, but when you roll 2 die, there's 36 possible outcomes, right? 6 times 6. So the probability that the numbers are different, it's going to be a lot easier to figure out how many ways they could be the same, right? Because the ways that they're the same, it's either both 1s, both 2s, both 3, both 4, both 5, both 6. So there's only 6 possible ways for them to be the same. So for this particular one, I'm going to take 1 and subtract the probability that you get the same number. Okay, and like we just said, there's 6 different ways to roll the same number twice out of 36 possible outcomes. And then I can subtract that. So on my calculator, I'm doing 1 minus 6 divided by 36. So that is 0.833. So there's an 83.3% chance that the numbers will be different. Okay? Because the only possible outcomes is that either the numbers are different or they're the same. Right? There's nothing else that could possibly happen. So if I subtract away all the ways they could be the same, it's going to leave me with the ways they could be different. All right, next one. 2 6-sided dice are thrown. There's 36 possibilities, so still we got that part. We want to find the probability of each event. So find the probability that the sum is not 6. Okay, well, if we want to find the probability that the sum is not 6, we'd have to look at all the different ways that these 36 possible outcomes add together and figure out how many of them don't add up to 6. Okay? Or I could say, well, let me take the probability of getting 6, okay, or getting a sum of 6. Okay, so 1 minus the probability of getting 6. Getting 6 or not getting 6, that's the entire sample space. There's no other option. So if I subtract the ways you can get 6 when you roll 2 dice, it's going to leave me with the ways that you cannot get 6. So how many ways can we add to 6? So let's see, 1 and 5 adds to 6, 2 and 4, 3 and 3, 4 and 2, 5 and 1. So there's 1, 2, 3, 4, 5 different ways. So there's 5 ways out of 36 so that they would add to 6. So in my calculator, I'm going to do 1 minus 5 out of 36. So that is 0.861 or 86.1%. All right, and then this guy here, the sum is less than or equal to 9. Okay, so again, the only possible outcomes here is that your sum is less than or equal to 9 or it's greater than 9, right? So in this case, what I'm going to do is I'm going to do 1 minus the probability that the sum is greater than 9. Okay? Why? Because there's lots of different ways that you can add up to smaller numbers, but like the highest number that you can add to in a die is 12, right? So all I have to look at for my cases is just 10, 11, and 12 if I use the complement. Okay, if I want to do less than or equal to 9, I'd have to do ways to add to 2, 3, 4, 5, 6, 7, 8, or 9. So looking at just the ways to add to 10, 11, or 12 is going to save me a lot of time. So ways to get 10, it could be 4 and 6, 5 and 5, 6 and 4. 11, 5 and 6, or 6 and 5. And 12 would have to be 6 and 6. So there's 3, 4, 5, 6 ways. So 6 out of 36. Okay, so that works out to 0.833 or 83.3%. Happen to be the same number as that one, so I could just kind of copy it. Okay, so there were 6 ways for what we didn't want to have happen, right? If we had actually just counted up the ways that it could actually be less than or equal to 9, there would be 30 different ways for that to happen, right? So it would have taken a lot longer for us to count them all up. All right, last one. A group of 6 students is being chosen from a selection pool of 15 of each of the types of students. Okay, what's the probability that at least 2 of the people chosen are seniors? Okay, so we're choosing 6 students and we want at least 2 of them to be seniors. So if we go about this directly, we'd have to find the number of ways to get 2 seniors, 3 seniors, 4 seniors, 5 seniors, and 6 seniors. That's a lot. So what I'm going to do is I'm going to use a complement. I'm going to do 1 minus the probability that you have 0 or 1 senior, because those are the only possible outcomes. Okay, you either have 0 or 1 seniors or you have 2 or more. Okay, so we're going to calculate this out. We're going to have to do a little bit of side work here, okay? So when we're looking at our probability of 0 or 1 seniors, so kind of breaking this one down, these ones, because it was all just dice, the denominator and the numerator were pretty easy to find. Okay, so this one's going to take a little bit more work for us. Okay, so remember the top part, we're going to look at the, the number of ways, right, to get 0 or 1 senior. Okay, so we're going to have to sort of break this into cases. So case number 1 is going to be if we have 0 seniors, we're choosing 6. And if none of them are seniors, that's 15, 30, 45 options, right? So 45, 44, 43, 42, 41, 40. The order in which they're selected doesn't matter. So I'm going to divide that by 6 factorial. Okay, then I'm going to add to that. So this was 0 seniors. Now we're going to add to having 1 senior. So if I have 1 senior, 6 slots, this one has to be a senior. And then these guys can be anything but a senior, right? So 45, 44, 43, 42, 41. Divide that by 5 factorial. Make that a little bit longer. Okay, so let's calculate. So 45 times 44 times 43 times 42 times 41 times 40, dividing that by 6 factorial. Okay, so that's one number. All right, and then we're going to have to calculate 15 times 15 times 45, times 44 times 43 times 42 times 41 divided by 5 factorial. Okay, and those are the two numbers I'm adding together, so I'm going to add that first one. So that's a big number there. So 19877,825. A lot of different ways. All right, now let's take a look at our denominator. So this is going to be the total number of ways that we could select 6 people. So only one case here. There are a total of 60 people. So 60, 59, 58, 57, 56, 55. Divide that by 6 factorial because the order doesn't matter. Okay, and that works out to this very, very large number. Should always be less than, all right, the denominator should always be more than the numerator, right? Okay, cool. So then I just have to divide those two numbers and that will give me my probability. So 19877,825 divided by the previous answer, that works out to a 0.397 or 39.7%. Okay. But this right here, what is this, right? This is the probability to get 0 or 1 senior. So to actually finish this problem off, I shouldn't have drawn the box around it. I did it automatically. That was a mistake. Okay, so to finish this problem off, now I have to actually do this final calculation. So I have to actually look at this and say, all right, so I want to do 1 minus this 0.397 number. So I'm going to do 1 minus that answer. And the actual answer to my question is a 60.3% chance. So this is the actual probability of having at least 2. Okay, whereas this guy is the probability of having 0 or 1 senior. Okay, and together the two of those add up to 100%. Okay, so that is the idea of a complement. Really, 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 really useful things to be able to use. Okay, and the key times that you want to use them is if there's any time it says something about at least or at most or less than or something like that, when you have cases that you'd have to break it down into, those are usually the times that you want to implement a complement. Okay, so when you have to break something into cases, that's usually when it's easiest. Sometimes it'll be easiest in other ones, but anytime you do a problem and you look at it and you're like, oh man, this is going to be so much work to figure out, that's a good time to pause and say, well, would it be easier with a complement?